10.1 Lines and segments that intersect circles. Can I identify special segments and lines in a circle? Can I use properties of tangents for circles? Stop the screencast for a minute and take a look at the vocabulary. If it's vocabulary you haven't seen, go ahead and write it down with its definition and a picture. Let's go ahead and do some problems to see if we can identify the vocabulary. First is AC. AC goes from the circle to the center, so that is known as a radius. Second vocabulary word is from A, the circle, through the center to the other side, and that's known as a diameter. DE, notice DE is outside the circle, but it does intersect the circle at one spot, so it's called a tangent. So it intersects at one point. Next one is AE, and here's AE. Notice AE is a line and it intersects at 2 points. We call this a secant. It's a line that intersects not at 1 point, but at 2 points. Now there's no such thing as a line intersecting at 3 points of a circle. Here's some vocabulary about tangents. We have words like tangent circles, concentric circles, and we have vocabulary called common tangents. Common internal tangents intersect segments that join the centers of the two circles, where external do not intersect the segment that joins the centers of the two circles. Let's take a look at this situation. Instead of me drawing it, I'm just going to draw all the tangents so you don't have to wait to see me drawing. And notice that I drew in blue the common external tangents. So these are external. They hit the circle at one place for the other. So each circle gets intersected at one point, and it doesn't intersect this line between the two centers. And that's happening over here, and it's happening over here for the external tangents. Now the internal tangents are going to be red, and they are going to intersect this line. So they're going to intersect the circle, 1 point, intersect the other circle, 1 point, but they also cut through this line of centers. And so here's another one too. This one has only one because they're tangent circles at 1 point. They only intersect at one. This does not have an internal tangent. There's no way I can draw a line and it be a tangent. Tangents, remember, only intersect the circle at one spot. Your turn. Go ahead and see what you can do. Stop the screencast and then continue. And here are the answers. I gave the number and I identified which one were the internal and which one were the external. We have two tangents in this lesson. The first one is the tangent line to a circle theorem. And it says that when you have a tangent line, you can draw a radius to that tangent line in that one particular point, and that is going to be perpendicular. It's going to make a right angle. And that's because this is the shortest path. If we were to draw a line from the center to the line, notice that it has some exterior part where the radius intersects the tangent without going outside the circle. And that's why we have this perpendicular situation. The next one is called the external tangent congruence theorem, and it states when you have two tangents from the same point, these two tangents will end up being congruent. All right, let's go ahead and take a look at why. Let's take a look at the theorem. Now here are the two tangents right here. Now since they're tangents, I know they're making a right angle with a radius. And then I'm going to connect point P and S because I want to create two triangles. Now I know that the radii are congruent to each other, and that's right here. So that's going to be an S pair. I also know that this side is congruent to itself, so that'll be a reflexive, but it'll also represent a side. And because I have two right angles right here, a right angle here and a right angle here, I can say these two triangles are congruent by the HL congruence theorem. We have a hypotenuse and we have a leg. Now, once those triangles are congruent, we can say this is congruent to this, which is what I'm saying here, by CPCTC. All right, let's take a look at this situation and decide whether this is a tangent. All right, so what I'm wondering is this right here a right angle? Because if it's a right angle, then I can say it's a tangent. So let's take a look at the three numbers, 37, 35, and 12, and decide if these three numbers make a triangle, a right triangle. So we're going to use this relationship that we've seen before. I want to make sure that the 37 is in the C spot, and it doesn't really matter about the other two. So I'm going to use my calculator to figure out what 37 squared is. And that answer is 1,369. And when I go in my calculator, I'm going to get the same value. So this tells me they are equal. When this is equal, I know I have a right triangle. So this is a right angle. And so now I can answer the question, yes, ST is a tangent. Only way it could be a tangent is if it were perpendicular to the radius. All right, let's take a look at this situation. We're trying to find R, the radius. One of the things we know is that this is a right angle because tangents always make a right angle. And I know this portion right here represents the hypotenuse, and this represents a leg, and this represents a leg. So I'm going to use the Pythagorean theorem. I'm going to put the C plus 50, that's little plus little, and that's the R plus 50. And then here's my leg, R squared, and here's my other leg, 80 squared. Now I'm going to write this out twice because I want to use FOIL. Now remember, FOIL is first, R squared, outer, 50R, inner, 50R, plus last, which is 2,500, equals R squared plus 6,400. I'm going to be able to subtract R squared on both sides, and what's going to happen is I no longer have to work with it. I will have 100R, and I'm going to subtract 2,500 from the 6,400, and I'm going to get 3,900. Divide by 100, and I get 39. So one of my legs is 39. My other leg is 80, and my hypotenuse, I put a 39 over here, and that's going to be 89. So these three numbers are going to make a right triangle. Okay, it says that RS is tangent and RT is tangent. Since they're tangent from the same external point, I know they're congruent to each other. So 28 is equal to 3x plus 4. So 3x is equal to 24, and therefore x is equal to 8. So that's a value of 8 that makes both of those tangent to each other. Your turn. Take a minute to stop the screencast and then continue. And here are the answers. When you get to class tomorrow, we'll also do a construction. We'll be constructing a tangent line, and we'll be following these steps.